In this video we will study that how to make a chemical reaction more informative. Before this we studied how to write a chemical reaction as word equation and symbolic equation. But in those word or symbolic equations we don't know about various informations about a chemical reaction. So now we will study that how we can make a chemical reaction more informative, means many informations can be achieved, can be shown in a chemical reaction by writing various things. We can understand various conditions, various things, various informations about a chemical reaction. So now we will study that how can we make a chemical reaction more informative. So all of us, by writing physical states of the reactants and products. If in a chemical reaction if we write the physical states, and the physical states are solid state, liquid state and gaseous state. If we clarify, if we show these states in a chemical reaction, it means the chemical reaction will become more informative. We also would know about the states of the reactants and products, as whether they are in solid state, liquid state or gaseous state. So all of us we can write the physical states of the reactants and products to make a chemical reaction more informative. And the example: iron ferrum reacts with water, so ferrous oxide and hydrogen gas are formed. So in this reaction we can balance it by writing 3 and 4 and 4 here as coefficients that we will study in the next section. And here this iron is in solid state, water is as water vapor, steam, it means it is in gaseous form, and this ferrous oxide is as solid form, and the hydrogen is in gaseous form. So by writing the physical states as solid, gas, etc., we can make a chemical reaction more informative. Second, by writing solution forms, and we can clarify, we can represent that the reactant or the product is in which form, as soluble form, solution form. And solutions, we studied before that in a solution two things are there: one solvent and the second is solute. Both makes a solution. For example, if we take 10 gram of salt and we add this 10 gram salt in 90 milliliter of water, in that case two things are there: salt and water, and the thing that is prepared is solution. So this is salt solution in water. Salt is in lesser quantity and known as solute, and water is in more quantity and known as solvent. Solvent is the thing in which the another substance or the solute dissolves, and the substance which itself dissolves in the another substance is known as solute. So here salt is the solute and water is solvent, and both makes the solution. Here if the solvent is water, in that case the solution will be aqueous solution. If we dissolve salt in alcohol, wine, ether, acetone, benzene, etc., these all things are not water, but salt can dissolve in these things, these substances. In that case solution also will be formed, but in that case the solution will be known as non-aqueous solution. It means solvent is not water. If solvent is water, in that case the solution is aqueous solution. If water is not there as a solvent, Other than water, other solvents may be there as ether, acetone, alcohol, etc. In that case, the solution will be non-aqueous solution. So we can make a chemical reaction equation more informative by writing the solution form also, that these things is aqueous solution, in aqueous solution, or non-aqueous solution. For example, this lead nitrate, we dissolve it in water and makes a solution. That solution is aqueous solution because we dissolve lead nitrate in water, so it is aqueous solution. And potassium iodide, that is in solid form, and we dissolve it in water and makes a solution, that is also a aqueous solution. So both are in aqueous solution form. And products are potassium nitrate, that is also aqueous form, aqueous solution. It means this is dissolved in water. But here we can see that this is a new product, that is lead iodide, that does not dissolve in water. If we undisturbed that solution products in the container undisturbed for a long time, this will be deposited at the bottom. We can see that this substance does not dissolve in the solution. Here this dissolves in water, the solution, but this does not dissolve. So this type of substance that does not dissolve in the solution as product is known as precipitate, and shown as PPT. That settles down at the bottom and does not dissolve in the water, so it is shown as the arrow pointing towards downward direction. So in this the solution forms are shown as aqueous solution, aqueous solution. This is also aqueous solution. So we know that this substance is dissolved in water, this is also dissolved in water. In the solution of products, this dissolves in water, but this does not dissolve in water. So by writing aqueous solution or non-aqueous solutions, we can make a chemical reaction more informative. Third example, by writing concentration of a solution. Concentration means amount of solute in a given solution or solvent. So for example, if we take salt and water, and if we add more salt, in that case concentration of the solute or salt will be increased, so it will be concentrated. And if we add water, more water, and after that some quantity, some amount of water also added, in that case it will be diluted solution. So by writing concentration of a solution as writing concentrated solution or diluted solution, we can make a chemical reaction equation more informative. For example, copper, that is in solid form, HNO3, nitric acid, that is liquid form, and this is concentrated. It means it is dissolved, it is mixed in water, but this is concentrated. It means water's quantity is not so much in the solution, and the substance found as the products, copper nitrate, aqueous solution in the form of, and nitrogen dioxide, gaseous form, and water, liquid form. And by writing these 4, 2, 2 as coefficients, we make it balanced. So concentrated, so it means this solution is, this liquid is as concentrated solution. Second example, as zinc H2SO4, it means sulfuric acid, this is liquid form, and zinc sulfate, aqueous form, hydrogen, gaseous form. And here we can see that this H2SO4 is not concentrated, it is as diluted solution. So here we write as DIL dot, it means it is diluted solution, and here CO and C dot, it means it is concentrated solution. The fourth way or method of making an equation or chemical reaction more informative, by showing the formation of a gas or a precipitate. In a chemical reaction, a gas may be formed or a precipitate may be formed. So how can we show or represent this formation of a gas or a precipitate? If a gas is formed, we can show the gas by writing an arrow pointing towards upward direction. And if a precipitate is formed in precipitation reaction, we can show it by writing PPT or by showing an arrow that is pointing towards downward direction, as formation of gas can be shown as the arrow pointing upward direction, and formation of a precipitate can be shown by an arrow pointing towards downward direction or by writing the PPT, precipitate. For example, potassium chlorate, the products are potassium chloride and oxygen. So oxygen is the gas that is formed during this chemical reaction. So this formation of gas can be shown by an arrow that is pointing in upward direction. And lead nitrate and potassium iodide react with each other, and as a product potassium nitrate is formed and a substance lead iodide, and lead iodide does not dissolve in the solution, and it is as a solid form that does not dissolve, as a solid powder, yellow colored powder form that does not dissolve in the solution. So this is a precipitate, and this reaction is also an example of precipitation reaction. So this formation of precipitate can be shown as by writing PPT or by an arrow pointing towards downward direction. So, and now other way of making a chemical reaction more informative by showing heat or heating. And as you know that this heating or providing heat is shown by a sign that is delta sign. Example, CaCO3 marble calcium carbonate heated at high temperature 600 to 1000 degrees Celsius, and calcium oxide and carbon dioxide gas is formed. So the formation of carbon dioxide here also shown is an arrow that is pointing upward direction, and in this reaction we are providing heat. We heating the content, heating the reactants, so it is shown by this sign, delta sign. Another example, ferrous sulfate heated and ferric oxide and sulfur dioxide and sulfur trioxide gases are formed. So if we provide heat or we heat the content or reactants, in that case we show it by this sign, or we can write here HEAT, heat also, but in a shorter form we can show it by this sign, delta sign. Next, by showing release or absorption of energy as heat, light or electricity. In some chemical reactions, heat can be absorbed or heat is needed to complete the chemical reaction, or during a chemical reaction heat can be also released. So this releasing or absorption of heat also shown in the chemical reaction to make it more informative. For example, if heat is released, it means release of heat. In that case the reaction will be exothermic reaction, and heat is released in exothermic reaction. In that case with the products we add heat with plus sign. So plus heat with products can be shown as the release of heat. For example, CaO, calcium oxide and water react with each other and form calcium hydroxide, and heat is also released. So this is an example of exothermic reaction, and heat is evolved, heat is released. So this releasing of heat can be shown as plus heat. So this is extra information that is making the chemical reaction more informative. It means we are knowing that heat is also released. So by these methods or these ways we can make a chemical reaction more informative. In some chemical reactions, heat is absorbed or heat is given to complete the reaction. This type of reactions are known as endothermic reactions, in which heat is absorbed. So absorption of heat can be shown by this sign. It means with products we write heat with minus sign with products. So for example, nitrogen gas and oxygen gas react with each other and form nitrogen monoxide. In this reaction, heat is absorbed, heat is given to the reactants to complete the reaction. So absorption of heat is shown as minus heat. It is written with the product. This shows that heat is taken in or heat is absorbed. This type of reactions are known as endothermic reactions. And if we touch the container will become cold. It means this cooling is due to heat is absorbed to complete the reaction. So this type of reactions are known as endothermic reactions. Next method to make a chemical reaction more informative, by writing reaction conditions. Reaction conditions means some reactions require some specific conditions. These reactions cannot take place without these specific conditions. For example, photosynthesis process, in which green plants can prepare their own food by the process of photosynthesis, and they need sunlight for this reaction. So this is the specific condition to prepare the food by the process of photosynthesis. And in photosynthesis we know that carbon dioxide and water react with each other and form glucose, carbohydrate. So this formation of glucose or carbohydrate can take place with a specific condition, need of sunlight. Without sunlight it cannot take place. So it is a specific condition. So like this, there are some specific conditions which are required to complete the chemical reaction. These requirements may be of sunlight, may be of heat, may be of specific pressure, catalysts, or electricity. As electrolysis of water, if we pass electricity in water, in that case water splits into two things, hydrogen and oxygen gas. So this reaction needs electricity. So electricity is the specific condition to complete this reaction. Like this catalyst, earlier we studied that these are the chemicals, substances which do not take place in the chemical reaction. They only decrease or increase the speed or rate of chemical reaction. It means due to the presence of these specific chemicals, the reaction can take place fastly or slowly. So these are the chemicals which can slow down or can increase the rate or speed of chemical reaction. These are known as catalysts. So some reactions need the requirement of these catalysts. For example, if these requirements or these conditions of the reactions are required, in that case we write these requirements or conditions below or above the arrow that we put between the reactants and products. So we write these things: sunlight, heat, pressure, catalyst, electricity, etc., which are the specific conditions needed to complete a chemical reaction. We write these things above or below the arrow in the chemical equation. For example, CO2 and H2O. It means water and carbon dioxide reacts with each other to form carbohydrate or glucose C6H12O6, and oxygen gas is also released, and in next sections we will study that water is also released. So to react, these two reactants need specific conditions. First is chlorophyll, second is sunlight. So in the absence of sunlight, this reaction cannot take place. So this is a specific conditions, or these specific requirements or conditions we write above or below the arrow. So by writing these conditions, we are making this chemical reaction more informative. And next or last, the way or method of making a chemical reaction more informative is reversible reactions. In some chemical reactions, the reactants form the products, and in specific conditions, the products again form the reactants. It means the reactants formed the products, and products in specific conditions again can form the reactants. So this type of reaction is known as reversible reaction. It means this type of reactions can be reversed. So these are reversible reactions. So we can write it as, it means reactants are forming the products, and products again forming the reactants. So we can show this type of reaction by a simple symbol, that is this sign. This sign shows the reversible reaction. For example, nitrogen gas and hydrogen gas in specific conditions react with each other and form ammonia, NH3. And again this ammonia, that is the product of these reactants, again can form these reactants in specific conditions. It means these reactants form the product, and in specific conditions this product again can form the reactants. So this type of reactions that can take place in both the directions, or we can say reactants can form products and products can form reactants again. This type of reactions are known as reversible reactions. So in place of the common arrow, we place this type of sign between the reactants and products, or in place of the arrow, by showing that this reaction is reversible reactions. Many other things may be there, but these are the common ways or methods to make a chemical reaction more informative, and we consider that by using these methods or ways we can make a chemical reaction more informative. So by writing these, we understand various things, various conditions, various things about a chemical reaction. So in this way we can make a chemical reaction more informative.